The Bloch sphere is a geometric way to picture a two-state quantum system. The vertical axis, the z-axis, corresponds to the difference in population between the two pointer states, how likely we are to find 0 versus 1. The equatorial plane, that is, the xy plane, represents the coherences of a qubit. These coherences correspond to the off-diagonal element of the density matrix, written as ρ01. The distance from the z-axis within that plane represents the magnitude of this element, written as the absolute value of ρ01. The angle around the equator represents the complex phase of ρ01. Now map pure dephasing onto that sphere. Pure dephasing does not change populations. The z-coordinate stays the same. It shrinks the transverse radius, the distance from the z-axis. That is, it reduces absolute value of ρ01. On the Bloch sphere, this looks like a point at some latitude spiraling in toward the z-axis while rotating around it. Rotation from the coherent omega term. If the environment forgets instantly, Markovian, the transverse radius decays smoothly and monotonically toward 0. The point moves straight inward to the z-axis and then stops rotating coherently. If the environment does not forget, non-Markovian, the transverse radius can partially grow again at later times. The point on the Bloch sphere can move back outward a bit, a revival, because the environment feeds coherence back to the system. In phase language, that corresponds to the amplitude of oscillations in the equatorial coordinates coming back temporarily. So, defacing equals shrinking toward the z-axis. Non-Markovian memory equals temporary outward nudges that partially restore the equatorial radius.